Hello and welcome to Startup Hack. Today we are going to talk about building secure APIs with .NET Core Authentication. So let's jump right in. Make sure to check out the link down below because we always provide the code samples that you can pull down and follow along so you can see in our project. Alright, let's start with creating a new project of Web API in ASP.NET Core, .NET 7. So after that, to begin our journey into securing API endpoints, let's discuss the API key authentication class, which integrates middleware and constants into one cohesive piece. This approach not only makes implementation easy, but also improves code readability and manageability. So here's our middleware code. So what are constants? API key section and API key header name are constants that designated the configuration section for retrieving our API key and the expected header name in HTTP request respectively. By embedding them directly within our class, we have localized their usage, fostering more readable and maintainable code. So you can see there. Do you want to earn $100,000 a year? Do you want to become a software developer within just 3 months? With our amazing course and awesome tutors, you never have to worry about getting stuck. We help students to learn skills that companies want to hire. We are Startup Hack. Don't forget to subscribe our channel. So let's get started. Okay, now request delegate. At the heart of ASP.NET Core middleware is the request delegate. This delegate is used to process HTTP request in pipeline. Essentially, it represents the next middleware component in the sequence. By invoking next context, we are passing control to the subsequent middleware or the final action if no other middleware exists. So what is iConfiguration? The iConfiguration interface provides access to configuration data from various sources like app settings, environment variables, and others. We use this to fetch the legitimate API key against which we will verify incoming requests. So moving towards the invoke sync method, which accepts an instance of HTTP context representing all the information about an individual HTTP request. Using HTTP context, we can access details like headers, query strings, and cookies. It also lets us modify the HTTP response. Within our invoke async method, we first check if the request headers contain the expected API key header, API key header name. If not found, a 401 unauthorized status is prompt return. Otherwise, we retrieve our genuine API key from the configuration and compare it against the received one. If there is a mismatch, a 401 status is returned once again. By leveraging inherent ASP.NET Core constructs such as request delegate and HTTP context, we take advantage of the framework's robustness and efficiency for our security needs. Okay, now configuring app settings.json for API key storage. Safeguarding your API demands a secure yet easily accessible method for storing API keys. The app settings.json file in .NET Core applications serves as a centralized location for app-related configurations details, making it an ideal spot to store our API key. Let's walk through how we modify it to accommodate our API key while maintaining a clean structure. So structuring app settings.json. So here's example. In this setup, authentication, a higher level section that deals exclusively with all related configurations, API key, a subsection key with authentication that holds the API key. Replace this key with your actual secure API key, whichever you like. So I have added this key. So okay, now structuring a secure endpoint in program.cs file. When crafting a minimal API using .NET Core 7, program.cs becomes the nexus of your application setup and configuration. Within this file, you weave together various components, middleware, and endpoints to conjure your API. Let's construct and comprehend an example featuring secure API endpoint. So here's example. With the use middleware method, we introduce our custom API key authentication middleware into the request pipeline. Every incoming request will traverse through this middleware, ensuring only requests with a valid API key gain further access. Okay, now defining a secured endpoint. Utilizing map-get, we establish a get endpoint at the path slash API. The second parameter, a lambda expression, defines a response when the endpoint is accessed. In our case, it responds with a string secured API endpoint. Thanks to our middleware, this endpoint is secure, demanding a valid API key in the request header for access. Okay, when I run this application, so in our first scenario, we'll send a request without supplying an API key, expecting a 401 unauthorized response. So that is the response, 401 unauthorized, and response body is API key is required. Next, we'll dispatch a request with an incorrect API key, anticipating another 401 status, so it's giving me the 401 invalid API key, and I have passed this key from on the headers. So finally, a request armed with the correct API should be yield access to our secure endpoint. So I have sent my current API key and on the get status now it says secured API endpoint. So thank you for watching this video. As technologies evolve, so do the methods and threat vectors. Staying up to date with advances and potential vulnerabilities can help you continuously improve and strengthen your API security. So don't forget to subscribe our channel and hit the bell icon for latest updates. To joining our course, you can simply go to our website called startuphack.com. Thank you.